In this question, it shows that there are two charged particles on an axis. The charges are free to move. At one point, however, a third charged particle can be placed so that all three particles are in equilibrium. So based on this information, we have to find the position of the third particle. In the second one, we have to find the polarity of the third charge, whether it is positive or negative. And in the third one, we have to find the system is a stable equilibrium or unstable in equilibrium. So first, it is clearly mentioned that the two charges are free to move. It means that these two charges are not in the equilibrium position. So we can understand this question based on two cases. In the case 1, we consider a third charged particle as positive. So we have three positions to place the third charge. One is on the left side of A, next is on the right side of B, and third is between A and B. If we take the first one, where the third particle is on the left side of A, so what will happen? This A will attract the charge C and B will repel the charge C. So we know one relation that force is inversely proportional to the square of the distance between them and force is directly proportional to the charge. So what will happen if you see the magnitude of A is 3 times more than the magnitude of B and the distance of A is near to the charge C than the distance of B to the charge C. So from that we can say that force of CA is greater than force of CB. So no equilibrium is formed in this case. Second, if we take the charged particle between A and B, so A will attract the charge C and B will repel the charge C. So in this case, both the forces are in the same direction, so no equilibrium will be formed. Now the last condition here at C, B will repel the C and A try to attract the C. And if you compare the forces at B, what will happen? C will repel the B and A will attract the B. So here C might be in the equilibrium but B will not be in the equilibrium. So that's why this condition is not fulfilled. And one more thing we got it from that, we can't take third charge as positive because when we take the positive in all the cases there is no equilibrium formed. Let's move to the case number 2 where we consider our third charge as negative. If we take the negative charge in the left side of A, so A is already negative and C is also negative, so they will repel each other. Similarly with respect to B, it will be attracted. But as we know, the magnitude of B is less than A and the distance of B to C is more than the distance of AC. So here force of CA is greater than force of CB. So equilibrium is not fulfilled here. And if you want to see with respect to A, so what will happen? B will attract A and C will repel A. So what will happen? Equilibrium will not be formed here. Now, if we take the negative charge between A and B, so A will repel and B will attract. So no equilibrium could be possible. Now let's go to the last case. So what will happen? B will attract the charge C and A will repel. So here the distance between AC is more than the distance of BC. So here it could be possible that forces are equal. So let's check with the point B. At B what happened? C will attract the B and A will attract the B. C and B both are in the equilibrium. Why? Because the distance of BC is less than the distance of AB. So we can say that equilibrium is possible on the right side. Second, the third charge must be negative. And in the third question, they are asking whether it is a stable equilibrium or unstable equilibrium. So what will happen if we try to move this charge little bit towards the right or left? It will not come back to the original position. It will be the example of unstable equilibrium.